So now we're going to officially start our grade 11 curriculum with simplifying rational expressions. Now, first of all, what is a rational expression? You can see down here we have a couple examples, but a rational expression is the quotient of two polynomials. So if you take a look, 3 divided by k minus 1, those are both two polynomials. 3 is a monomial, a single term. K minus 1 is a binomial, two terms. Now, the next one, x squared plus y squared divided by 2x minus y, is a binomial divided by a binomial. What you can essentially think of this as, it's a fraction with different polynomials in the numerator and denominator. Now, we're going to be doing all sorts of operations that we would with fractions, also with rational expressions. So things like simplifying, multiplying, dividing, adding, subtracting, all that. Now, just a little bit of review. When we are simplifying or reducing a fraction, so let's say I have a fraction such as 6 over 8. We want to reduce that to lowest terms, and that's actually what our lesson is going to be today with rational expressions. Now, in order to simplify a fraction like this, what we have to do officially is common factor both the numerator and the denominator, and we want to find the same common factor on the top and the bottom if we can. So it turns out between 6 and 8, we can both factor out a 2. So 2 times 3 is 6, 2 times 4 is 8. Now at this point, if we have 2 times 3, and that's divided by 2 times 4, now there's no addition or subtraction happening here, this allows us to divide out the 2's. Now just remember, we've talked about this before, 2 divided by 2 is not nothing. You do get a 1, but because we're multiplying by 1, on the 3 and on the 4, then it's kind of meaningless. So this gives us a fraction of 3 over 4, which is equivalent to the original 6 over 8. That's going to be our goal today for rational expressions, and this is the exact same thing we're going to be doing, finding common factors and seeing if we can divide them out. So we'll take a look at this first example. Now, the question says simplify and state the restriction. We're going to talk about stating the restriction a little bit later on. We're going to focus on the simplifying for now. So x squared minus x divided by x. The first step we're going to do, we're going to factor the numerator and denominator, always starting with common factoring. So it might be a trinomial or a difference of squares, anything like that, but always starting with common factoring. Now, these aren't trinomials that we have here, so we're going to try common factoring. Now, between x squared minus x, I can factor out an x, and I'm left with x minus 1. Now, my denominator, there's nothing to really factor there, but because I know that I have a common factor of x in the numerator, I am going to factor out an x, but what that actually leaves me with is a 1. Now, at this point, if you have the same common factor in the numerator and denominator, they divide to 1, just like I showed you with the fractions. So those x's are now eliminated, they're gone. So what we're left with, and our final answer here, is x minus 1 divided by 1. Now, as you know, dividing by 1 is meaningless, so our answer is simply x minus 1. And that's actually equivalent to what we started with, x squared minus x divided by x. Now, the final thing we have to do, we have to say, are there any restrictions on what x can be? Now, to figure that out, you may have learned this in other math courses. You can try this out on your calculators if you want, but try any number divided by 0. You can't do it. All right, dividing by 0 is not possible in math. So basically what we have to make sure is that at no point in our question, in our solution, can the denominator be equal to 0. So what is the only way that that can happen? The only way that can happen here is if x is equal to 0. So what we have to say is x cannot be equal to 0, because that would make this denominator equal to 0, and then, well, that wouldn't be good for us. So we have to say that x cannot be equal to 0, because if you were to just look at the final answer, x minus 1, well, yeah, x could be equal to 0, because 0 minus 1, well, that's possible. But in the original question, or in the second step that we had, that would actually give us a denominator of 0, and that's not allowed. So we do have to state these restrictions for any question we do. So this was a little introduction to simplifying rational expressions. We'll go through the rest in class.